What if we could teach computers to think less like, well, a machine and a little more like us? That's exactly what we're diving into today with a powerful idea called fuzzy logic.
Okay, let me ask you a simple question. Is it hot outside? Now, your answer probably isn't just a straight yes or no, right? You'd probably say something like, kinda, or a little, or, oh yeah, it's unbearably hot. And believe it or not, that simple little question points to a huge challenge for computers.
See, the problem is that computers, traditionally, they run on what's called Boolean logic. For them, everything is black and white. It's a yes or a no, a true or a false, a 1 or a 0. But our world, human logic, oh, it's filled with all this nuance. We live in the gray areas.
Right? The world isn't binary, so why should our logic have to be? If we want to get machines to reason with that human-like nuance, we're going to need a totally different approach. And this is where our hero, fuzzy logic, comes into the picture. Instead of forcing this choice between 100% true or 100% false, fuzzy logic lets us have degrees of truth. An idea can be, say, 80% true and 20% false at the exact same time.
Now, while the name fuzzy logic was famously coined by the mathematician Lotfi Zadeh back in 1965, the actual idea, this concept of a logic with more than just two values, it's been kicking around for a lot longer. The groundwork was actually being laid way back in the 1920s.
Okay, this is a really important point. We need to be clear that this is not the same as probability. Probability is all about the chance of something happening. You know, like a coin flip. Is it going to be heads or tails? Fuzzy logic, on the other hand, is about vagueness. It's not about if it will be hot, it's about defining what hot even means in the first place, especially when there's no single sharp cutoff.
All right, so how does this stuff actually work in the real world? Let's break it down with a classic example. We're going to build a smart controller for a fan.
So, a typical fuzzy system works in 3 main stages. It's actually pretty logical. You start with a precise number, you fuzzify it into a more general idea, you apply some simple rules, and then you defuzzify that result back into a precise number that the machine can actually use.
Okay, so step 1, fuzzification. What we do here is take a crisp, precise input, like, say, an exact temperature reading from a sensor, and the whole goal is to translate that number into those vague, human-like terms we all use, like cold, warm, or hot. And check this out. This is a great way to visualize what's happening. See that vertical line? That's our one specific temperature reading. But notice how it's not just one thing. It actually has a membership value in multiple categories at once. It's maybe 80% cold and 20% warm simultaneously. It's a little bit of both, and that's the key. All right, next up, the system moves on to applying some rules. This is where we give the machine a kind of rule book. But here's the cool part. It's not written in some super complex code. It's all written in simple, plain language if-then statements that anyone can understand.
So for our fan controller, the rules are just common sense, right? If the temperature is hot, then the fan speed should be high. It's super intuitive because we're basically just programming in common sense.
So what's happening under the hood to make all this flexibility possible? Well, it's about redefining those old logic rules. In classic Boolean logic, if you have 2 conditions with an and between them, both have to be 100% true for the whole thing to be true. But in fuzzy logic, the and operator often just becomes a min function. It just looks at the 2 conditions and takes whichever truth value is lower. And that simple change is what lets the system handle all that messy in-between information.
And that brings us to our final step, defuzzification. The system now takes all the outputs from all the different rules that got triggered. Maybe it's thinking moderately slow from one rule and slightly moderate from another, and it combines all of them to figure out one single concrete command.
And here is the magic. After all that thinking about vague ideas like warm and slow, the system spits out one single precise command. Set the fan speed to 275 RPM. It has successfully translated that human-like nuance into a clear action that a machine can actually perform. Pretty cool, huh?
So this is way more than just a cool theory. You would probably be shocked to learn how often this fuzzy kind of thinking is built into the tech you use every single day without you even realizing it.
I mean, look at this list. It's everywhere. From the control systems on the Sendai subway in Japan that make the ride incredibly smooth, to those single-button washing machines that just know how to wash your clothes, all the way to improving your car's fuel efficiency. It's this hidden layer of intelligence that's just making things work better. And it's true. Japan was a huge early pioneer in actually applying fuzzy logic in the commercial world.
They really demonstrated its power to improve just about everything, from comfort and precision in things like trains to making everyday home appliances way more efficient.
Okay, so let's tie this all together. What's the big takeaway here? Why is this whole idea of embracing vagueness so incredibly powerful?
When you get right down to it, the real power of fuzzy logic is that it can handle imprecise, vague information so gracefully. By letting our machines see the world in shades of gray, we can build systems that are way more flexible, more efficient, and honestly, more intuitive. And why? Because they're finally thinking a little bit more like we do.
And that leaves us with a final question for you. Now that you get how fuzzy logic works by thinking in these shades of gray, where do you see a place for it? What's a complex black and white problem out there that you think could be solved by adding just a little bit of fuzziness?